Close your eyes. Imagine a time when there was no time at all. There was no matter, no cities, no countries, no continents, no Earth, no stars, no galaxies, and no universe. There was no space either. There was so little emptiness that even nothingness didn't exist. In other words, at one point in time, even time itself did not exist. Everything, you and me, all of us, everything, was in a single point. Squeezed into a point even smaller than the tiniest dot you could ever make on a piece of paper with the tip of a pen, we were all right there. Everything we have ever seen or will ever see was inside that point. The universe was a single point. Shall we go to that point? To that moment? Forget all the incredible moments, wars, all developments, and everything else that has ever happened in human history. Come on, let's go to indisputably the most important moment in history. Let's rewind time a little bit and go to the moment where time and everything began, the Big Bang. The Big Bang is currently accepted as one of the most famous theories in the history of science regarding the universe. We know it to be true through countless observations and evidence, though opinions on how it happened can vary. Like many theories, the Big Bang theory emerged less than a century ago. Until then, the universe was thought to be static, eternal, meaning without a beginning, and always existing. However, in the early 1920s, Edwin Hubble, working at an observatory in California, would shatter this perception. Observing galaxies from the observatory, Hubble would notice that the further away galaxies were from us, the more their light waves stretched, the greater the distance light waves traveled, the more their wavelength stretched, and that this stretching or expansion changed the wavelength of the light. Just like in sound waves, where the pitch of an object increases as it approaches us, or more precisely, its sound frequency shortens, and as it moves away, that frequency stretches and stretches. Galaxies were just like this. As they moved away from us, the frequency of their light waves also expanded and became redder, so to speak. That is why we call it redshift. Thus, when we looked deep into space, we saw this redshift everywhere. All galaxies looked as if they were running away from somewhere, moving away. If something is moving away, what does that mean? Naturally, that it set out from somewhere. This told us one single thing: all galaxies, all stars, everything came from one place, from a single place. Hubble's finding would introduce an extraordinary concept. It was the first proof that the universe had a beginning. This was the starting point of the Big Bang theory. However, to go to that exact moment, to the moment where everything began, and to understand what happened, we once again have to throw away our concept of time as we know and perceive it. You know, days, hours, minutes, a single second means absolutely nothing to us. While I am reading this sentence and you are watching this, a few seconds have passed. In fact, it passed in the blink of an eye. Isn't it very short? We blink in 150 milliseconds, yet an entire universe can be born in a span billions of times shorter than the speed of a blink. So forget about minutes and all that, we are going to talk about extremely short durations. The first is Planck time, 10 to the power of minus 43 seconds, meaning 0 point followed by 42 zeros and a 1. An unimaginably short time, in fact, the shortest time accessible in the universe. Yet, the things that happen within this incredibly short time give birth to and bring forth everything that will play out over 13.8 billion years. That is why we will break down a single second, as we know it, into ages. Starting from the 0th second, this point is called singularity, meaning the moment where everything is one, the moment where all matter and energies, all of us, fit into a single point. This density and temperature at that moment are almost infinite energy and matter, so hot that you cannot separate them. E equals mc squared. We had said that energy and matter are the same thing, right? Well, at that moment, they truly were the same thing, forming a single entity. There are four fundamental forces, right? Gravity, electromagnetism, strong and weak nuclear forces. Well, at that moment, they too exist as a single force. As a single fundamental force. There is an incredible symmetry in the universe at that moment. Everything is actually one, and at that moment, the width of the universe is 10 to the power of minus 35 meters, reaching the shortest possible distance, the Planck length. Yet, compared to nothingness, it is actually an incredible length. As for the temperature, it is 10 to the power of 32 degrees Celsius. We call this the Planck temperature. It is the absolute temperature, the opposite of absolute zero. And we have left behind the first era of the universe. And not even a single Planck time has passed, a time trillion times shorter than a second. Then a new era begins, the grand unification era, between 10 to the power of minus 43 seconds and 10 to the power of minus 36 seconds. Here, at this moment, gravity separates itself from the single fundamental force. Electromagnetism and nuclear forces still exist as a single force, and also at this moment, the first fundamental particles begin to emerge, and of course, antiparticles as well. Then things get very messy. Inflation, what we call an explosion, but as we will discuss in a moment, rather than an explosion, a massive expansion era begins, continuing up to 10 to the power of minus 32 seconds. At this point, when the strong nuclear force separates itself from the other forces, an insanely rapid expansion process called cosmic inflation takes place, and the universe expands from the size of an atom to 10 centimeters in such a short time. I mean, stating it like this might not make it fully understandable, but this is equivalent to an object the size of a nanometer, meaning half of a DNA molecule, reaching a width of 94 kilometers in that short amount of time. An incredible environment. At this point, under immense temperature and pressure, particles known as quark soup and quark gluon plasma are spread across the universe. Following this crazy expansion, the electroweak era begins, where the electromagnetic force and the weak nuclear force are one. Come on, not even a single second has passed yet, there is still a long way to go. Particles interact with each other and form W, Z, and Higgs bosons. At this point, the Higgs field begins to show its effect and things start gaining mass, and the universe transforms into a ball of radiation that will support everything that has mass. At 10 to the power of minus 12 seconds, the quark era begins. The universe's temperature drops from nearly infinite to below 10 quadrillion degrees. Quarks, electrons, and neutrinos begin to form, and the four fundamental forces are almost completely separated and coming into being. However, the battle continues. While particles exist, of course, antiparticles also form, and by destroying each other, they continue to release massive amounts of energy and expand the universe at an incredible speed. Exactly at this moment, matter wins over antimatter, meaning quarks win over antiquarks by a margin of 1 in a billion, and matter wins, and we come into being. If that asymmetry hadn't existed, nothing would exist. And at 10 to the power of -6 seconds, the Hadron era begins. Let me remind you again, a single second has not passed yet. The universe cools down quite a bit. While cooling down, the temperature is about 1 trillion degrees. But this temperature is sufficient for quarks to combine and form protons and neutrons. Electrons collide with protons to form neutrinos, and these neutrinos are still here today, wandering around everywhere. And finally, we have left behind 1 second. An infinitely short duration for us, like eternity for the universe. But it is not over. The period starting from 1 second up to the 3rd minute is called the lepton era. After hadrons, like quarks and antiquarks, matter and antimatter annihilated each other. Particles like leptons, meaning electrons, and antileptons, meaning positrons, began to form the mass of the universe. And when electrons and positrons annihilated each other, energy in the form of photons began to emerge. Photons also began colliding with each other, forming electron-positron pairs. A cycle, an energy-filled cycle, a magnificent battle. After the 3rd minute, the nucleosynthesis era begins, lasting up to 20 minutes. Here, the temperature of the universe drops down to 1 billion degrees, and at this temperature, atomic nuclei begin to form for the first time. Yes, protons and neutrons can only form the nuclei of light elements such as hydrogen, helium, and lithium through nuclear fusion. After the 20th minute, however, the density and temperature of the universe drop to such a degree that nuclear fusion can no longer occur, and from this point on, the photon era begins. Radiation dominance, and this era lasts quite a long time, about 240,000 years. At this stage, the universe cools down further, and an era of a universe filled with plasma, consisting only of atomic nuclei and electrons where photons cannot escape, meaning impermeable to light, takes place. A large part of its energy continues to exist in the form of photons, but the presence of photons does not mean there is light. The photons are not free. The period starting 240,000 years later up to 300,000 years later is the recombination era. Because the temperature drops down to 3,000 degrees, electrons combine with nuclei, atoms finally begin to form, and photons are finally set free. Now the universe begins to let light pass through. At the end of this period, the universe is filled with a gas cloud consisting of 75% hydrogen, 25% helium, and a small amount of lithium. Afterwards, the Dark Ages begin. We call it the Dark Ages because, even though photons are now free, up until 150 million years later, no stars have formed yet, so there is no formation to emit light. Therefore, it is still completely dark everywhere, and very little happens during this period. This period passes under the domination of dark matter. Very little happens over vast spans of time. Unlike the first second, between 300 to 500 million years, the first stars and galaxies begin to emerge one by one. The first stars were short-lived, supermassive stars, hundreds of times larger than our Sun. However, these stars, lacking metals, collapsed under the effect of gravity in a very short time and exploded in a supernova, beginning to form new elements and new stars. Afterwards, galaxies, galaxy clusters, and superclusters formed. You know the rest: solar systems, planets, and about 4.5 billion years ago, our system formed, and then you, me, and all of us. An incredible journey, magnificent. This is an incredible origin story, one we can follow second by turning the machinery back with giant telescopes and following the light. But no matter how big of a telescope we build, there is one single thing we cannot see. What was there before the Big Bang? This is a huge question. A heavy question. In fact, it is a kind of philosophical question, the place where humanity hits a dead end in every sense. We have no idea. None at all. Because now, we need to talk about the misconception of the term explosion in the Big Bang theory. We should call it something like singular expansion instead. However, when we say explosion, it is important to understand that it is not an event like what we imagine in our minds. For an explosion to happen, there must be a reaction into something, meaning inside the space of an entity. What happened here was not an explosion. The universe did not exist. At that moment, there was an expansion, an existence taking place. It was actually something expanding into itself, an existence existing within nothingness. So the question is, what was this thing called the Big Bang inside of? We see what is inside of it, but what was outside of the Big Bang? The universe doesn't matter. What was there when the universe didn't exist? Right now, we have no idea about the answers to these questions. However, there are some models, some potential answers that have not been proven yet. But we will definitely talk about these, and science today is working with all its might to make sense of this nothingness. Every day we get a little closer. Perhaps we will never find the answers to some questions. But the beauty of science is that it just keeps moving forward without caring about anything, saying, there will be no unanswered questions left. Perhaps one day we will discuss together the answers to some questions that are said to be unanswerable here. At the center of our solar system lies an entity so vast, so powerful, and so overwhelming that it commands the absolute obedience of everything around it. We call it the Sun. To our eyes, looking up from the safe shelter of a small blue planet millions of miles away, it appears as a gentle, warm golden disk, painting our mornings with light and our evenings with soft hues of orange and red. But that gentle appearance is a grand illusion. Beneath that peaceful facade lies a roaring, titanic furnace of unimaginable fury and scale. It is a star, a master of gravity, a sovereign ruling over an empire of worlds, holding them captive in an eternal, silent, and elegant dance through the dark. How massive is this golden giant? We speak of numbers that defy human comprehension, figures that stretch our imagination beyond its breaking point. You could take our Earth, with all its oceans, its towering mountains, its sweeping continents, and its billions of lives, and you could swallow it whole inside the Sun. In fact, you could repeat this feat over and over again, packing 1,300,000 Earths into the belly of this single star, and it would still have room to spare. Its gravity is an invisible web stretching across millions of kilometers, pulling on planets, moons, and drifting comets, keeping them locked in their paths so they are never lost to the cold, empty void of interstellar space. Deep inside its core, hidden far away from the gaze of any telescope, a relentless and violent process unfolds every microsecond. Under a crushing, oppressive pressure that no human mind can truly visualize, and temperatures that soar into millions of degrees, atoms are continuously smashed together through nuclear fusion. Hydrogen is fused into helium, and in that violent marriage of particles, an incomprehensible amount of energy is born. This brilliant, blinding light is forged in the deepest heart of the star, but it cannot escape easily. It begins a long, agonizingly slow journey, trapped in a chaotic maze of dense plasma. A single photon of light, born in the fiery core, takes over 100,000 years just to claw its way from the center to the surface. It bounces, it scatters, it struggles for eons through layers of unimaginable density before it finally breaks free into the vacuum of space, completing its journey to our eyes in just 8 minutes. Every single second, 4,000,000 tons of matter are completely annihilated and converted into pure raw energy. The scale of this consumption is terrifying. Yet, despite its fierce and violent nature, spitting colossal solar flares, eruptions of magnetized plasma that loop thousands of miles into space, and coronal mass ejections that could swallow our entire planet as if it were a speck of dust, it radiates a steady, ancient, and reliable warmth. It is this exact balance, this quiet persistence, that allowed life to take root on a small rocky world drifting far away in the dark. Imagine floating in the silence of space, watching this great sphere of fire twist and turn across the ages. The solar wind whispers outward, carrying energetic particles across the solar system, brushing against the edges of distant worlds. There is no sound here. Space is an absolute vacuum, devoid of air, carrying no echoes of the roaring nuclear reactions happening within the star. It is a profound, meditative silence, broken only by the steady, unyielding pulse of light and gravity. As we linger here in the golden embrace of our star, let the sheer, staggering scale of it wash over you. Think of the distance it bridges, the warmth it provides, and the eternal vigilance with which it guards its system. The sun is a relentless engine of creation and destruction, burning through its vast reserves of fuel day after day, year after year, second by second, ticking like a cosmic clock that has been running for billions of years and will run for billions more before its story finally draws to a close. Let the weight of this fiery giant ground your thoughts, carrying you deeper into the quiet stillness of the cosmos, where time loses its meaning and only the endless light remains. Deep in the cold, desolate, and mysterious depths of our solar system lies a rusty, copper-toned, and solitary world that has captured human imagination, fears, exploration urges, and deepest curiosities for centuries. Mars. The red planet. Its average distance from the Sun is about 228 million kilometers, which is a considerable distance even by space standards, roughly 1.5 astronomical units. The life-giving light and heat waves born from the heart of the Sun must travel through the endless, dark void of space for approximately 12.5 minutes, or exactly 750 seconds, just to cross this immense distance. This distance alone is the very first sign of how detached and isolated it is, spinning in its own lonely orbit far away from our safe home. When we look up into the night sky from Earth, our neighbor Mars shines like a small, reddish point of light, holding a rather modest position in terms of size within the family of planets. Its diameter is approximately 6,779 kilometers, making it the second smallest planet in the solar system, right after Mercury. In terms of size, it is nearly half as large as our magnificent blue home. When we consider the massive volume of our Earth, we could easily fit about 6 Mars globes inside it. Yet, its total surface area is roughly equivalent to the total dry land surface area of Earth, because the vast oceans that cover our planet do not exist on Mars. The distance between Earth and Mars is never fixed, because the orbits of both planets around the Sun flow at different speeds and trace out ellipses. The distance between them constantly shifts, almost as if it were breathing. During moments of close approach alignment, the distance between them drops down to about 54 million kilometers, while in their most distant positions when they are on opposite sides of the Sun, this gap can expand to a massive 401 million kilometers. If you were to embark on a journey from Earth to Mars traveling at that cosmic speed which knows no obstacles in the vacuum of space, the pure speed of light at 300,000 kilometers per second, this journey would take anywhere from just 3 minutes during a close approach, to a maximum of 22 minutes at its most distant position to reach the dusty soils of the red planet. Today, when we look at Mars from the outside through the cold window of space, it appears to be a cold, silent desert continuously whipped by thin and fragile winds, covered in iron rust, mustard yellow, ash gray, and orange dust. Yet, if you look a bit closer at its ancient surface soils hidden beneath the rocks and craters, you can clearly see the ghosts of a primordial, water-rich past. Once upon a time, this planet hosted massive floods, roaring rivers, lakes, and perhaps vast, shallow oceans covering its northern hemisphere. Dried-up ancient riverbeds, gigantic canyon systems stretching for thousands of kilometers that make Earth's Grand Canyon look like a child's toy, and Olympus Mons, the highest known volcano in the entire solar system, rise right here in the middle of this red silence. Reaching 22 kilometers from base to peak, meaning more than 3 times taller than Mount Everest and covering an area roughly the size of France, this colossal volcanic mountain stands as the absolute proof of what massive tectonic and volcanic forces once raged across this world, tearing its crust apart. Mars preserves the secrets of a youth that faded away billions of years ago, a missed cosmic opportunity. Perhaps it harbors the traces of an era when it was warm, wet, possessing a thick atmosphere, and full of life just like our own home, safely hidden beneath its soil. Its atmosphere is so thin that it fails to filter out harmful ultraviolet radiation from the sun. Its surface pressure is so low that liquid water immediately evaporates in the open air. Right now, it slumbers beneath a pale, pinkish, and rusty sky, wrapped in the deep, eerie, and hypnotic silence of a Martian night. On the surface, almost no sound can be heard other than the faint whisper of wind softly brushing against ancient rocks as they sweep through the thin carbon dioxide atmosphere. Imagine floating here in this infinity, observing this rusty horizon line alongside the fast and peculiar sky passages of its 2 small, misshapen moons, Phobos and Deimos. Time flows much slower here than it does on our world, as if the universe itself has paused to listen to the fairy tale of this red desert. Feel the red dust settling like velvet over your thoughts and mind, washing away the exhausting daily rush, noise, and all chaos, leaving behind a deep, unbreakable peace within your soul. In this silent, lonely, yet fascinating corner of space, enjoy resting as a part of a billion-year-old cosmic story, becoming weightless, and gently letting yourself drift into the infinity of the universe. Deep in the dark, frozen, and breathtaking outer reaches of our solar system lies a magnificent, ringed world that has captivated human wonder, astronomical curiosity, and deep night sky observations for centuries. Saturn, the jewel of the solar system. Its average distance from the Sun is about 1.4 billion kilometers, which translates to a staggering 9.5 astronomical units away from our burning star. The life-giving light and heat waves born from the heart of the Sun must travel through the endless, freezing void of space for approximately 80 minutes, nearly an hour and 20 minutes, just to cross this vast cosmic gulf and touch the pale, golden cloud tops of the gas giant. This immense distance places Saturn in a perpetual twilight realm, far removed from the warmth of the inner worlds, spinning in majestic isolation. When we look up into the night sky from Earth with even a modest telescope, Saturn reveals itself as a stunning celestial object, second in size only to Jupiter among the wandering planets. Its equatorial diameter is approximately 116,460 kilometers, making it nearly 9 times wider than our own Earth. In terms of sheer volume, you could pack more than 760 Earths inside the colossal body of Saturn and still have room left over. Yet, despite its enormous size, Saturn possesses a bizarre and poetic physical property. It is the least dense planet in the entire solar system. Composed overwhelmingly of hydrogen and helium gas, Saturn is actually lighter than water. If you could somehow find a cosmic ocean big enough to hold it, the entire planet of Saturn would float like a giant, golden ball on the water. The distance between Earth and Saturn is in a state of constant, slow flux as both worlds trace their massive elliptical paths around the Sun at very different speeds. During moments of opposition when Earth passes directly between Saturn and the Sun, the distance between us shrinks to about 1.2 billion kilometers. Conversely, when Saturn swings around to the opposite side of the solar system, that gulf expands to over 1.6 billion kilometers. If you were to embark on a journey from Earth to Saturn traveling at that ultimate cosmic limit, the pure speed of light at 300,000 kilometers per second, the trip would take anywhere from 67 minutes at its closest approach to nearly 90 minutes when the ring giant is furthest away. Today, when we gaze at Saturn through the cold window of space, its most defining and miraculous feature immediately commands attention: its dazzling system of rings. These iconic rings are not solid sheets or ribbons of painted light. They are composed of countless billions of individual particles of ice and rocky debris, ranging from microscopic dust grains to towering mountains of frozen water, all locked in a delicate, shining, perpetual orbital dance around the equator. Spanning hundreds of thousands of kilometers across yet measuring only about 10 meters thick in most places, the rings represent the remnants of ancient comets, asteroids, or shattered icy moons torn apart by Saturn's immense tidal forces long ago. Beneath these shimmering halos lies a turbulent, storm-swept atmosphere of golden hues, whipped by jet streams that roar at speeds far exceeding the strongest hurricane winds on Earth. Saturn holds the secrets of a vast family, serving as the master of an intricate moon system containing over 100 known satellites. Among them is Titan, the second largest moon in the solar system, which boasts a thick, orange nitrogen atmosphere and secret, stable lakes of liquid methane and ethane on its freezing surface, the only other place in the solar system besides Earth known to host surface liquids. There is also Enceladus, a small, icy world hiding a global subsurface ocean of liquid water that shoots dramatic geysers of ice and organic molecules straight out into space through cracks in its southern crust. These fascinating moons add layers of profound mystery to the golden giant's domain. Right now, Saturn slumbers beneath its hazy, multi-layered cloud decks, wrapped in the deep, serene, and hypnotic silence of the outer solar system. On its cloud tops, howling winds sweep endlessly through an atmosphere of crushing pressures and freezing temperatures that plummet to -178 degrees Celsius. Imagine floating here in the deep dark of space, observing this magnificent golden sphere and its crystalline rings tilted at a graceful angle toward the distant, faint Sunday time flows with a slow, hypnotic grace out here, as if the universe itself has paused to watch the eternal rotation of the rings. Feel the golden stardust settling like velvet over your thoughts and mind, washing away the exhausting daily rush, noise, and all chaos, leaving behind a deep, unbreakable peace within your soul. In this silent, majestic, yet fascinating corner of space, enjoy resting as a part of a billion-year-old cosmic story, becoming weightless, and gently letting yourself drift into the infinity of the universe. Deep in the vast, tempestuous, and majestic realm of the outer solar system lies a colossal world that commands absolute dominance over its neighbors, acting as the undisputed king of the planets. Jupiter, the gas giant. Its average distance from the Sun is about 778 million kilometers, which translates to a remarkable 5.2 astronomical units away from our burning star. The life-giving light and heat waves born from the heart of the Sun must travel through the endless, cold void of space for approximately 43 minutes just to cross this immense cosmic gulf and illuminate the swirling, amber cloud decks of the giant. This vast distance places Jupiter far beyond the warm inner worlds, guarding the outer solar system as a silent, powerful sentinel. When we look up into the night sky from Earth, Jupiter shines as one of the brightest and most captivating points of light, second only to Venus and the Moon on most nights. In terms of sheer size, it is a behemoth that dwarfs everything else in the planetary family. Its equatorial diameter is approximately 139,820 kilometers, making it nearly 11 times wider than our own Earth. When we consider the massive volume of our home planet, you could pack more than 1,300 Earths inside the colossal body of Jupiter and still have plenty of room to spare. In fact, if you combined every other planet, moon, and asteroid in the entire solar system into one single mass, Jupiter would still be larger than all of them combined. Despite this unbelievable scale, it is composed almost entirely of swirling hydrogen and helium gas, possessing no solid surface to walk upon. The distance between Earth and Jupiter is in a state of constant, slow flux as both worlds trace their elliptical paths around the Sun at very different speeds. During moments of opposition when Earth passes directly between Jupiter and the Sun, the distance between us shrinks to about 588 million kilometers. Conversely, when Jupiter swings around to the opposite side of the solar system, that gulf expands to over 968 million kilometers. If you were to embark on a journey from Earth to Jupiter traveling at that ultimate cosmic limit, the pure speed of light at 300,000 kilometers per second, the trip would take anywhere from 33 minutes at its closest approach to nearly 54 minutes when the gas giant is furthest away. Today, when we gaze at Jupiter through the cold window of space, its most defining and miraculous feature immediately commands attention: its turbulent, storm-swept atmosphere. Painted in breathtaking bands of amber, cream, ochre, and deep brown, the planet is whipped by jet streams flowing in opposite directions at hundreds of kilometers per hour. Stamped permanently onto its stormy face is the Great Red Spot, a raging, immortal tempest, a colossal storm twice the size of Earth itself, that has been howling across the planet's atmosphere for centuries. Beneath these colorful cloud tops lie layers of compressed hydrogen transitioning into a vast ocean of liquid metallic hydrogen, creating the strongest planetary magnetic field in the solar system, a protective, invisible shield stretching millions of kilometers into space. Jupiter holds the secrets of a miniature solar system, serving as the master of an intricate moon family containing nearly 100 known satellites. Among them are the 4 massive Galilean moons discovered by Galileo Galilei, Io, the most volcanically active body in the solar system, covered in sulfur lakes and exploding plumes; Europa, a smooth, icy world hiding a global subsurface ocean of liquid water with more potential for life than Earth; Ganymede, the largest moon in the solar system, even bigger than the planet Mercury; and Callisto, an ancient, heavily cratered world scarred by the dawn of creation. Furthermore, Jupiter acts as a massive gravitational shield for the inner solar system, pulling wandering comets and asteroids away from us and protecting our vulnerable blue home from catastrophic impacts. Right now, Jupiter slumbers beneath its roaring, multi-layered cloud decks, wrapped in the deep, resonant, and hypnotic hum of the outer solar system. Deep within its core, pressures rise to unimaginable extremes, crushing matter into exotic states while storms rage endlessly in the dark. Imagine floating here in the deep dark of space, observing this magnificent golden brown sphere twist and turn across the ages, its majestic storm swirling in eternal silence. Time flows with a slow, hypnotic grace out here, as if the universe itself has paused to watch the endless rotation of the King of Planets. Feel the cosmic stardust settling like velvet over your thoughts and mind, washing away the exhausting daily rush, noise, and all chaos, leaving behind a deep, unbreakable peace within your soul. In this silent, majestic, yet fascinating corner of space, enjoy resting as a part of a billion-year-old cosmic story, becoming weightless, and gently letting yourself drift into the infinity of the universe. Deep in the inner sanctum of our solar system, standing closer to the blazing heart of our star than any other world, lies Mercury. The swift planet. Its average distance from the Sun is about 58 million kilometers, which translates to a mere 0.38 astronomical units away from our burning star. Because it is caught in the intense gravitational grip of the Sun, the life-giving light and heat waves born from its core must travel through the endless vacuum of space for only about 3 minutes and 20 seconds, roughly 200 seconds, to reach the scorched, cratered surface of this tiny world. This extreme proximity places Mercury in a realm of blistering fire and absolute extremes, spinning alone in the blinding glare of the solar furnace. When we look at Mercury from the perspective of the solar system, it stands as the smallest of all the major planets. Its equatorial diameter is approximately 4,880 kilometers, making it only slightly larger than Earth's moon and barely larger than the dwarf planet Pluto. In terms of sheer volume, you could pack nearly 18 Mercury globes inside the body of our own Earth. Despite its tiny stature, it is an extraordinarily dense world, possessing a massive iron core that makes up about 85% of its entire radius, suggesting that it was stripped of its outer rocky mantle by a colossal, catastrophic impact in the distant violent past. The distance between Earth and Mercury is in a state of constant, rapid flux as both worlds race along their elliptical paths around the Sun at very different speeds. During moments of closest approach, when Mercury passes between Earth and the Sun, the distance between us shrinks to about 77 million kilometers. Conversely, when Mercury swings around to the far side of its orbit behind the Sun, that gulf expands to over 222 million kilometers. If you were to embark on a journey from Earth to Mercury traveling at that ultimate cosmic limit, the pure speed of light at 300,000 kilometers per second, the trip would take anywhere from just over 4 minutes at its closest approach to nearly 12.5 minutes when the innermost planet is furthest away. Today, when we gaze at Mercury through the cold window of space, its most defining and miraculous feature immediately commands attention: its extreme environment and battered face. Because it has virtually no atmosphere to trap heat or cushion impacts, Mercury experiences the most extreme temperature fluctuations in the entire solar system. The side facing the Sun bakes in a relentless, blistering heat that reaches a scorching 430 degrees Celsius, hot enough to melt lead, while the dark side freezes in an absolute, bone-chilling vacuum where temperatures plummet to -180 degrees Celsius. Its surface is heavily scarred with deep, ancient craters, massive impact basins like Caloris, and towering cliffs hundreds of kilometers long that formed billions of years ago when the planet's massive iron core cooled and shrank, wrinkling its rocky crust like a dried fruit. Mercury holds the secrets of the innermost frontier, serving as a silent, heavily battered witness to the violent formation of the inner solar system. With no moons to accompany it and no atmosphere to protect it, it endures a perpetual cosmic bombardment from solar winds and passing micrometeoroids. Yet, hidden deep inside its permanent shadow-filled polar craters, trapped away from the burning sun forever, lie deposits of water ice, a stunning paradox of fire and ice locked in the heart of the innermost world. Right now, Mercury slumbers beneath the blistering glare of the sun, wrapped in the deep, silent, and motionless vacuum of space. On its scarred surface, the silence is absolute, broken only by the slow, eternal turning of the stars. Imagine floating here in the raw, unfiltered sunlight of the inner solar system, observing this gray, heavily cratered sphere spinning through the cosmic dust. Time flows with a slow, hypnotic grace out here, as if the universe itself has paused to watch the endless dance of the innermost wanderer. Feel the ancient cosmic dust settling like velvet over your thoughts and mind, washing away the exhausting daily rush, noise, and all chaos, leaving behind a deep, unbreakable peace within your soul. In this silent, stark, yet fascinating corner of space, enjoy resting as a part of a billion-year-old cosmic story, becoming weightless, and gently letting yourself drift into the infinity of the universe. Deep in the inner sanctum of our solar system, shining brighter than almost any other star in our night sky, lies Venus. The evening star. Its average distance from the Sun is about 108 million kilometers, which translates to roughly 0.72 astronomical units away from our burning star. The life-giving light and heat waves born from the heart of the Sun must travel through the endless vacuum of space for approximately 6 minutes just to cross this cosmic gulf and illuminate the thick, velvety golden clouds of this mysterious world. This close proximity places Venus as our nearest planetary neighbor, yet it remains one of the most hostile and hidden realms in the cosmos. When we look at Venus from the perspective of the solar system, it stands remarkably close to Earth in size, often earning the title of our planet's twin. Its equatorial diameter is approximately 12,104 kilometers, making it just slightly smaller than our own Earth. In terms of sheer volume, you could pack nearly equal numbers of Earth and Venus globes together, as our home planet is only about 5% larger. Yet, despite these similar dimensions, Venus evolved down a radically different path, transforming into a runaway greenhouse nightmare. The distance between Earth and Venus is in a state of constant, rapid flux as both worlds race along their elliptical paths around the Sun at different speeds. During moments of closest approach, when Venus passes nearest to Earth in its orbit, the distance between us shrinks to about 38 million kilometers, closer than any other major planet. Conversely, when Venus swings around to the far side of the Sun, that gulf expands to over 261 million kilometers. If you were to embark on a journey from Earth to Venus traveling at that ultimate cosmic limit, the pure speed of light at 300,000 kilometers per second, the trip would take anywhere from just over 2 minutes at its closest approach to nearly 15 minutes when the veiled planet is furthest away. Today, when we gaze at Venus through the cold window of space, its most defining and miraculous feature immediately commands attention: its thick, blindingly bright atmosphere. Composed overwhelmingly of carbon dioxide with heavy, permanent layers of clouds made of sulfuric acid droplets, it traps the heat of the Sun in a relentless greenhouse effect. This makes Venus the hottest planet in the entire solar system, even hotter than Mercury, with surface temperatures soaring to a blistering 465 degrees Celsius, hot enough to melt lead. The atmospheric pressure at its surface is crushing, 90 times heavier than Earth's, equivalent to being nearly a kilometer deep underwater. Beneath this heavy, toxic shroud lies a volcanic landscape of vast plains, twisted tectonic fractures, and towering shield volcanoes like Mat Mons. Venus holds the secrets of a planetary paradox, spinning backward on its axis in a retrograde motion so slow that a single day on Venus, one complete rotation, takes 243 Earth days, lasting even longer than its entire year of 225 Earth days. With no moons to accompany it and a magnetic field nearly non-existent, it stands in solitary defiance against the solar wind. Right now, Venus slumbers beneath its heavy, glowing shroud of clouds, wrapped in the deep, muffled, and hypnotic silence of a runaway atmospheric furnace. On its harsh surface, the wind whispers faintly across molten rock plains under a perpetual, amber-tinted twilight. Imagine floating here in the dense, hazy upper atmosphere of the twin planet, observing this bright, golden sphere spinning slowly through the dark void. Time flows with a slow, hypnotic grace out here, as if the universe itself has paused to watch the eternal mystery of the veiled world. Feel the cosmic stardust settling like velvet over your thoughts and mind, washing away the exhausting daily rush, noise, and all chaos, leaving behind a deep, unbreakable peace within your soul. In this silent, mysterious, yet fascinating corner of space, enjoy resting as a part of a billion-year-old cosmic story, becoming weightless, and gently letting yourself drift into the infinity of the universe. Deep in the freezing, shadowy twilight of the outer solar system, shining as a pale, ghost-like cyan sphere, lies Uranus, the ice giant. Its average distance from the Sun is about 2.87 billion kilometers, which translates to a staggering 19.2 astronomical units away from our burning star. The life-giving light and heat waves born from the heart of the Sun must travel through the endless, freezing void of space for approximately 160 minutes, nearly 2 hours and 40 minutes, just to cross this vast cosmic gulf and touch the cold, featureless cloud tops of this distant world. This immense distance places Uranus in a realm of profound solitude, far removed from the warmth of the inner planets. When we look at Uranus from the perspective of the solar system, it stands as the third largest planet in terms of size, dwarfing our rocky home. Its equatorial diameter is approximately 51,118 kilometers, making it roughly 4 times wider than our own Earth. In terms of sheer volume, you could pack more than 63 Earths inside the colossal body of Uranus and still have room to spare. Despite its massive scale, it is composed largely of a freezing slush of water, ammonia, and methane surrounding a small rocky core, wrapped in a cold, pastel blue atmosphere of hydrogen, helium, and methane gas. The distance between Earth and Uranus is in a state of constant, slow flux as both worlds trace their massive elliptical paths around the Sun at very different speeds. During moments of opposition when Earth passes directly between Uranus and the Sun, the distance between us shrinks to about 2.57 billion kilometers. Conversely, when Uranus swings around to the opposite side of the solar system, that gulf expands to over 3.15 billion kilometers. If you were to embark on a journey from Earth to Uranus traveling at that ultimate cosmic limit, the pure speed of light at 300,000 kilometers per second, the trip would take anywhere from 143 minutes at its closest approach to nearly 175 minutes when the ice giant is furthest away. Today, when we gaze at Uranus through the cold window of space, its most defining and miraculous feature immediately commands attention: its extreme and unnatural axial tilt. Unlike any other major world in the solar system, Uranus is tilted almost completely 90 degrees on its side, rolling along its orbital path like a ball on a smooth, endless floor. Astronomers believe a colossal, catastrophic collision with an Earth-sized protoplanet in the distant violent past knocked it completely off balance. Because of this extreme tilt, each of its poles experiences 21 long years of continuous, blazing sunlight, followed by 21 years of absolute, freezing, starless darkness. Encircling its equator is a faint, dark system of rings accompanied by a family of dozens of icy moons named after characters from the works of Shakespeare and Alexander Pope. Uranus holds the secrets of the outer cold, serving as a silent, rolling wanderer in the deep twilight. With temperatures in its upper atmosphere plunging to -224 degrees Celsius, it holds the record for the coldest planetary atmosphere in the entire solar system, even colder than Neptune despite being closer to the Sun. Right now, Uranus slumbers beneath its pale, cyan cloud decks, wrapped in the deep, serene, and hypnotic silence of the distant void. In its freezing atmosphere, winds whisper softly through a world of permanent ice and mystery. Imagine floating here in the deep dark of space, observing this pale, tilted blue sphere rolling slowly through the cosmic dust. Time flows with a slow, hypnotic grace out here, as if the universe itself has paused to watch the endless rotation of the sideways ice giant. Feel the cosmic stardust settling like velvet over your thoughts and mind, washing away the exhausting daily rush, noise, and all chaos, leaving behind a deep, unbreakable peace within your soul. In this silent, mysterious, yet fascinating corner of space, enjoy resting as a part of a billion-year-old cosmic story, becoming weightless, and gently letting yourself drift into the infinity of the universe. Deep in the freezing, sapphire blue frontiers of the outer solar system, where the warmth of our star is nothing more than a distant memory, lies Neptune. The windiest world. Its average distance from the Sun is about 4.5 billion kilometers, which translates to a staggering 30 astronomical units away from our burning star. The life-giving light and heat waves born from the heart of the Sun must travel through the endless, dark void of space for approximately 240 minutes, a full 4 hours, just to cross this immense cosmic gulf and illuminate the vivid, stormy cloud tops of this distant giant. This extreme distance places Neptune at the very edge of the planetary realm, guarding the final borders against the vast, open ocean of interstellar space. When we look at Neptune from the perspective of the solar system, it stands as the fourth largest planet in terms of diameter, yet it is the densest of the ice giants. Its equatorial diameter is approximately 49,244 kilometers, making it nearly 4 times wider than our own Earth. In terms of sheer volume, you could pack roughly 57 Earths inside the colossal body of Neptune and still have room to spare. Despite being slightly smaller in diameter than its neighbor Uranus, Neptune actually possesses a greater mass due to its denser internal composition of heavier elements, water, ammonia, and methane slush surrounding a rocky core. The distance between Earth and Neptune is in a state of constant, slow flux as both worlds trace their massive elliptical paths around the Sun at very different speeds. During moments of opposition when Earth passes directly between Neptune and the Sun, the distance between us shrinks to about 4.3 billion kilometers. Conversely, when Neptune swings around to the opposite side of the solar system, that gulf expands to over 4.7 billion kilometers. If you were to embark on a journey from Earth to Neptune traveling at that ultimate cosmic limit, the pure speed of light at 300,000 kilometers per second, the trip would take anywhere from 238 minutes at its closest approach to nearly 262 minutes when the sapphire giant is furthest away. Today, when we gaze at Neptune through the cold window of space, its most defining and miraculous feature immediately commands attention: its hypersonic winds and violent, dynamic atmosphere. Painted in a striking, deep azure blue, Neptune is whipped by the fastest and most ferocious winds found anywhere in the solar system. Winds here can scream across the planet at speeds exceeding 2,000 kilometers per hour, breaking the sound barrier and roaring faster than the most destructive hurricanes on Earth. Wispy, delicate bands of white methane ice clouds drift across its stormy face like ghostly cirrus formations, accompanied by massive, rotating dark storms similar to Jupiter's Great Red Spot. Because of its immense distance, a single year on Neptune takes 165 Earth years to complete, meaning it has barely completed a fraction of an orbit since humanity first discovered it in 1846. Neptune holds the secrets of the deep outer realms, serving as the master of a fascinating family of moons and faint rings. Among its satellites is Triton, a massive captured world that orbits Neptune in a backward, retrograde direction, the only large moon in the solar system to do so. Triton is a freezing, active wonderland featuring geysers of nitrogen gas erupting miles high into the thin vacuum, and an icy surface that slowly melts and refreezes over eons. Right now, Neptune slumbers beneath its howling, sapphire cloud decks, wrapped in the deep, serene, and hypnotic silence of the outer edge. In its freezing atmosphere, temperatures plummet to -214 degrees Celsius while supersonic storms rage endlessly in the dark. Imagine floating here in the deep dark of space, observing this vivid, sapphire blue sphere glowing softly against the infinite backdrop of stars. Time flows with a slow, hypnotic grace out here, as if the universe itself has paused to watch the eternal winds of the farthest planet. Feel the cosmic stardust settling like velvet over your thoughts and mind, washing away the exhausting daily rush, noise, and all chaos, leaving behind a deep, unbreakable peace within your soul. In this silent, majestic, yet fascinating corner of space, enjoy resting as a part of a billion-year-old cosmic story, becoming weightless, and gently letting yourself drift into the infinity of the universe.